Salmon start as eggs, then go to alvine, then go out to the ocean, and come back to reproduce and then die. Sediment, some sediment start at the top of mountains, and then make their way to the ocean via streams, creeks, and rivers, such as the Elwha. Sediment can either help or hurt the fish by killing them or making good places for them to breed. They're reds. Sediment will be able to freely move from the mountains, such as Mount Olympus, all the way to the ocean, and that could be a good part or a bad part depending on how fast the dams are removed. If they remove too quickly, the salmon could greatly injure the fish spawning. Large weight debris are trees that die and sometimes fall into these streams and rivers to become weight debris. The large weight debris affects salmon by blocking off water for them not to be able to go upstream, as well as redirecting rivers.
What you see across the river is a terrace that's been eroded away by the river, and it's showing you all the depositional events that have occurred over the last several hundred years. Dam removal is going to accelerate this whole process. There's a big delta terrace that's formed at the south end of Lake Mills. It has almost 9 million cubic yards of sand, mostly sand. It's also some gravels and a little bit of silt. That sediment is going to erode forward in an advancing delta during dam removal and lead to the whole valley bottom being covered in anywhere from 10 to 20 feet of sands and gravels. That's on top of what's already there, which right now we know fine sediments have accumulated over the last 100 years, and those fine sediment layers in the middle of the lake range from 10 to 40 feet thick. So that means 10 to 20 feet of sand deposited on top of 10 to 40 feet of fine sediments will lead to 20 to 60 foot terraces. And that's what we're going to have to revegetate after dam removal is complete. The river will cut back down through that sediment, create a healthy floodplain like you see here, but it's a half a mile wide, Lake Mills, and some of those terraces, those new deep terraces, will not be eroded away by the river. And so we will have these terraces like what you see over there, high and dry, that we are going to have to revegetate with anything that's drought tolerant, because it won't have access to water, and there'll be no organic matter, no soils to plant vegetation into.
How will the dam removals and the silt repositioning affect the fish?
Silt and clays, which make up more than half of the sediments that have accumulated, can negatively influence fish in the river. Basically, the turbidity level gets too high, can choke out aquatic life, including fish. Those impacts are expected to be brief. The river easily moves clays and silts, so we're expecting that to be no more than a 5-year impact. After that, sands and gravels should move, but not quite as easily, and they'll have a positive impact on fish because they'll replenish the rest of the river with sands and gravels. The river below the dams has been starved of these sediments, so salmon need gravels and sands for their reds. So right now there's a lot less area for them to reproduce because there's just not as many areas with sands and gravels. So over the long haul, this new input of sediments is going to be very positive to the ecosystem, both the fish ecosystem as well as vegetation. What we're looking at here is rare in the lower watershed because there aren't a lot of new sandy terraces. There's not enough sediment being inputted into that system anymore because of the two dams.
And how
dam removal is going to lead to a big influx of new sediment that have accumulated in the reservoirs. There's more than 18 million cubic yards. About half of that is sands and gravels, and that's what's surrounding me here. These are sandy terraces that are typical in a healthy floodplain ecosystem in the Elwha.
do you plan to revegetate areas like Lake Mills when the lake is starting to be drained by the removal of the Glen's Canyon Dam?
Well, we're going to take a slow approach to revegetating. 7 years during dam removal, when we're starting to see land exposed. We'll try some experiments to see what species do well. We'll plant some dense areas that we're calling facilitation patches. And then once dam removal is completely finished, We're going to seed the valley walls with grasses and forbs to try to hold those fine sediments in place, because the valley walls are only going to have fines. They won't have sands and gravels. And then we're going to start intensively planting the terraces with drought-tolerant species. And over that 7-year period, we'll have installed over 400,000 plants, all woody, and more than 5,000 pounds of seed.
Very cool.